Well, good morning, algebra. Here's our do now for today. Go ahead and count up the number of letters in your first name. We're going to split up. So if you've got an even number of letters in your first name, do that blue equation right here. You're just going to identify the slope and the y-intercept and then graph that line. And if first name's got an odd number of letters, we're going to do this green one right here. Identify the slope, the y-intercept, and then graph that one. We'll hang out until you're done. All right, nice job. Hey, so both of these, the equations in y equals mx plus b form, and so that means we just look at the number in the m spot right between the equal sign and the x. That'll be the slope, highlighted in yellow here. So for the blue equation, that is 3. If we write that as a fraction, we're going to get 3 over 1, so we can see the rise and the run. The y-intercept is the -4 at the end of the equation. For the green one, the slope is -1/2, again, right between the equal sign and the x. The y-intercept is +3 over there at the end. So you can see the green one on the graph right now without having to scroll. So let's take a look at that graph first. So I started here at +3 and then used the slope as the directions to get the next point. So down, because the slope is negative, down 1 space. That is my rise. The top number of the fraction there is the 1. And then to the right, 2 spaces, since that's the bottom number of the fraction, or the run. Okay, let's look at the blue one. So for the blue one, we're going to start at the y-intercept, which is -4. The y-axis obviously is the one that goes up and down. So I'm going to have to scroll so we can see that on the graph. I started at -4. That's my first dot. And then the slope was 3. We rewrote that as 3 over 1. And so that is the slope. I'm going to go from this point up 1, 2, 3 spaces, and then to the right 1 space. There's my line. So just go ahead and graph both of those on the same graph. That will be totally fine. End of do now. Nice job. So today we're going to look at solving systems of equations by graphing. And our learning targets, you'll be able to solve a system by graphing. So solving systems is like a unit of topics we'll be looking at here for the next couple of weeks. And there are 3 different methods that we will learn about how to solve a system. And graphing is the first of them. And let's go ahead and start off with some vocabulary words. First of all, system. So that is basically the unit of study that we're starting off here. And in math, system means the exact same thing that it means in any other class or any other subject that you've learned. It's a set or a group of connected parts. In this case, equations, connected equations, which form a complex whole. So you could have like an ecosystem that you learn about, in biology class, all these different animals and life forms, plants and things that are all connected together as part of a whole system. You could have like a circulatory system in your body, and same idea. So we got a couple of equations that we're going to look together as a group that forms a complex. It's got several parts, where we got a couple of different lines. And second vocabulary word is solution. The solution to a system is a point. And points have coordinates, an x coordinate and a y coordinate. It's an ordered pair. So solution is the coordinates, x and y coordinate, of the variables x and y, which satisfy all of the equations. And all makes it sound like so inclusive. I mean, it is, but there's only going to be 2 equations we're dealing with. So you're going to have an x and a y coordinate that would work in either of the, well, both of the equations, but either one at a time. That if you change the x and the y in the original equations to these numbers, it would give you a true number sentence. This thing equals that thing, and it would work. So the solution, the way we see this on a graph, is what we're going to look at today. We're solving things by graphing. Let's jump back to the do now. So we graphed these 2 equations on the same graph. We got a green equation and a blue equation. So this is, in fact, a system, because I've got 2 lines on the same graph. That's what a system looks like. And where those 2 lines cross one another at that red point right there, that is the solution. And so we'd identify that by coordinates. In this case, the coordinates of that point are 2, 2. And so we'd write that as an ordered pair. That's the solution. And just to illustrate the definition of what a solution means, it's the coordinates there. But we said on the definition page, it's the coordinates that would make both equations true. So if I were to take that 2 and substitute those back into the original blue and the original green equations for x and y, it would give me a true number sentence. Let's just look real fast. So y equals 3x minus 4. And the other one is y equals negative 1/2 x plus 3. Okay, let's go ahead and replace the x and the y in the blue equation. I'm going to change both of them into 2's since those are the coordinates of x and the coordinates of y. And let's go ahead and work out the right-hand side here. 3 times 2, that's 6. 6 minus 4 does actually equal 2. This works. All right, that's what we're looking for. Coordinates that will make that equation give us a true number sentence. If I scooch this green one down, then I've got a little bit more room. I can actually write that 2 equals. So when I finish subtracting on the right-hand side, 6 minus 4, that is 2. So 2 minus 2 equals 2. Super. Let's do the same thing here with the green one. I'm going to copy that, and let's change the x and the y both into 2's. And let's go ahead and work out the right-hand side. Negative 1/2 times 2, that's negative 1. And if I add together on the right-hand side, negative 1 plus 3, that actually does give me 2. So again, true number sentence. Hey, let's do another example. So I got 2 more equations here. Let's we're going to graph these both. Let's start with the blue one. So this blue equation has a slope of 1/2. So that's going to give me a rise going up 1 space and a run of 2 to the right. The y-intercept at the end of the equation right there is positive 3. Let's go ahead and graph this one. So on the y-axis, we're going to start at positive 3. And then we use the slope as directions to find our next point. So from that point, up 1 space, and then right 2 spaces, repeat. Up 1, right 2. Go ahead and draw a line. Grab my blue one. It's got squares on it, so I'm going to change those once I get this graphed. Change those into arrows. Okay, and then let's do the green one. So the green equation has got a slope of 3/2. So my run is going to be 3 up, and the run will be 2 to the right. The y-intercept right there at the end of the equation is negative 1. That's where I'm going to start from. Negative 1 on the y-axis. There's my starting point. And then from that point, use the slope to get the next direction, the next point. So these are my directions. So go up 3, 2, 3, and then right 2 spaces. Up 3, 1, 2, 3, and right 2 spaces. And wow, I can see where they're going to cross. Let's go ahead and get that line drawn. So this is going to be a dotted line. I will change this to a solid line. It's just what the stock value is. The default is a dotted line on this one. Get this changed to a solid line. Okay, so the directions are to find the solution, and that is where those 2 lines cross, where they meet or intersect. And in this case, it is that point right there. I'll put that big red dot there. And so I need the coordinates. I'm going to put my answer inside parentheses. The x coordinate first, I'm going to count sideways, and that is at 4. And then the y coordinate, I need to find out how much I'm going up. That is at 5. So the solution for this system is at the point 4, 5. All right.